Hi students, in this video we'll talk about Lab 9, Rock, Paper, Scissors. As you notice right here, Lab 9 in the current semester is marked as an extra credit lab. Okay? And being an extra credit lab at the moment, TAs will not be available to help you debug this lab, it's up to you, but we will be around to clarify any questions you have about the requirements. Okay? So there's a lot of material in this lab, but the purpose of this lab mainly is to give you experience with pointers and to give you practice creating your own classes. In Lab 8, we gave you a few files and we gave you a pre-made class, but this will be your first opportunity to create your own class from scratch. Okay, so let's just kind of run through the requirements, and then we have some slides and we have a demonstration to run for you. Part 1, main.cpp and player.h and .cpp files in your projects. So these are essentially free points that we give you. You need to have your main.cpp, your player.h, and your player.cpp files included in your project directory. The main.cpp needs to be able to access the class information provided by the player.h and player.cpp files. Okay? Whenever you zip up your project to submit it, make sure that all three files of this are included. If one of them is missing, when we go to look at it afterwards, it likely won't run. So part 2, create your main. So this is just saying that you need to have a CPP that contains your main function as well as your functions for your menu options. It's saying that there are a few required functions right here, and we'll talk about those. And it's also saying that your main function should have two vectors. The vectors will contain player pointers, and the vectors can be declared in this way: vector, type, player pointer, vector name. If your class is named something other than player, that identifier will replace player. Okay? So it's essentially saying whatever your player class name is, it could be player, it could be champion, it could be contestant, that would go right here, followed by the asterisk, denoting that the data type contained in this vector will be a pointer to the class type that you make. Okay? So one vector will be used to store pointers to all players that are added to the game. So every time that we're adding a new player to our system, we need to add a pointer to this vector, and let's call this vector the players vector that's pointing to a player. Okay? And then we're going to have another vector that'll be used to store pointers to players that are selected by the user from the vector containing pointers to all players. This vector will function as a queue. Whenever the fight option is selected, the next two players in this vector play RPS against one another and are then removed from this vector. So all of this is kind of confusing, but what you need to take away from this is that there will be two vectors. Both of these vectors will contain pointers to players. Okay? One vector, the player vector, this guy right here, will be used to store pointers to all players that are added to the game. So this vector is only going to grow. Okay? This other vector right here is going to be a vector of all of the contestants that are waiting to play in the rock, paper, scissors tournament. Okay? So we have some slides. Let's take a look at those and see if those help. Okay? So let's just get started kind of from scratch and give you an idea of how this is going to work conceptually. So right here it says creating players and adding player pointers to a vector. In this example, I want us to conceptualize adding player 1 to the tournament, and the way that I would do that is by saying player star player 1 equals new player. Okay? And note that that new is creating a block of memory to hold my player. Okay? This player right here, this white rectangle, that's going to represent my vector called players, and this guy is going to represent my block of memory where a player is actually contained. This arrow symbolizes that player 1 is really just a pointer to this block of objects. Okay? So make sure that you're not mixing this up. This is not an object, this is a pointer to an object. Okay, so by invoking this line, I put the dot 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 in here so you can put whatever you want for your constructor, but this is a constructor of some sort. So we've created a new player, and player 1 right here is a pointer. We've created a vector player pointers, and then I'm saying players dot pushback player 1. So I'm adding this pointer to the vector. Okay? This is all a little bit confusing, but if you run through this a couple times, it should make sense. Okay? So then let's just say that we've done the same thing. We've said player 2 equals new player, players.pushback, player 2, player 3 equals new player, and remember when I say player 3, I mean player 3 star. Okay, it's a pointer to a player, and then we add that to the vector. Okay, so then this is our total players. We only have 3 players in the system, but they all represent these players, and because none of them have competed in a rock, paper, scissors match, they all have 0 wins, 0 losses, and 0 draws. Okay. So next is adding players to the lineup. Remember that the lineup will be the second vector. So a few bullet points. Find the pointer in the player's vector that you want to add to the matchup vector. Okay. So if I wanted to add player 1 right here, that would be slot 0, players at slot 0. Note that both of these vectors contain player pointers, and push back the pointer in the player's vector into the matchup vector. So the way I could do that, if my matchup vector was just called matchup, I could say matchup.pushback players at slot 0. Okay? When you guys do this on your own, you'll notice that you're going to have to find the player by name, get the index, kind of like a find function, and then based on that index, wherever he's found in the player's vector, add it to the matchup vector. Okay, let's move on. So you see kind of just like this mess of stuff now. I've added a few players into our lineup just to kind of represent our overall queue as stated by the requirements. I put these arrows in the blue to remind us that all of these guys are pointing to this pointer, which is pointing to our actual object somewhere in memory. Player 2, green, player 3, red. And these weren't added in any particular order for any reason, but let's just say player 1 and player 2 are at the top of the queue. Okay? And then player 2, player 3, player 1, player 2. Notice that because I have 6 players in here, then we'll have at least 3 matches that we can run. Okay, the only way to take a player out of the lineup or the matchup vector is for them to actually participate in a rock, paper, scissors fight. Okay, so let's just do a couple examples of what this should mean, but let's talk about the fight requirements before we do so. Okay, so we talked about creating our main. Let's talk about fight. So you will take the first 2 players out of the vector of pointers of players waiting to compete, okay? Which in this case, the first 2 would be player 1 and player 1. You must verify that there are at least 2 players pointed to by the vector before you begin a match. Okay? So one other thing to point out here, while there are 6, and that is a multiple of 2, that would run. If this was just 5, it should also run. This isn't like Lab 7 where it has to be a power of 2 to start off with. Rather, there just have to be 2 participants to do the initial battle. Okay. You will then simulate a match between these 2 players by having each of them simulate a rock, paper, scissors throw by using the getRPSThrow member function. You will compare the results. The winner will increase his or her numbers of wins statistic, and the loser will increase his number of losses statistic. In the event of a draw, each player will increase his number of draws statistic. Okay? So the next 2 players in the vector of players waiting to compete should be available for the next match. Okay, so after you have a winner, a loser, or a draw, after any individual fight is completed, the 2 contestants that previously had fought need to be taken out of the matchup vector. Okay? But just remember, even though they're out of the matchup vector, you can still access those players because they're found in the players vector. Okay? So if the two players pointed to at the front of the vector of pointers to players waiting to compete are the same person, the result is an automatic draw. Only one draw should be added to that player. Both instances of the players are then removed. You should not print out any RPS throws. Okay? So in this example here, we see that player 1 is going to fight himself. He's in slot 0 and he's in slot 1. So that is going to result in an automatic draw. Okay? So now we can see player 1 is in red both times because it's symbolizing player 1 is going to go up against player 1. I've taken out all these arrows just because it was a little bit muddled. Okay? So we see that player 1 was taken out. No rock, paper, scissors or anything was printed out. It's just an automatic draw. And we can see that the change right here is player 1 got a single draw. Okay? So player 2 and player 3 are next up, meaning player 2 will fight player 3. Okay? So let's go on and see what happens. So player 2 and player 3 are at the top of the lineup vector. Player 2 and player 3 will randomly roll rock, paper, or scissors. And here's just an example of what your console could print out. It's up to you how you want to do it. You can be creative. The only thing we need to see is that player 2 throws rock, paper, or scissors, and that player 3 throws rock, paper, scissors with results. Okay? So let's say player 2 throws rock, player 3 throws paper, so player 3 wins. Just going to the next slide, we see that player 3 gets a win and player 2 gets a loss. Okay? And then we see that those two are removed from our lineup. So conceptually, that's all you're going to have to do. You're going to have to maintain this vector of your lineup, or your matchup, however you want to say it, and your players. Your players vector is only ever going to get bigger as you add new players to the system. Remember that all players that are added will start out with 0 wins, 0 losses, and 0 draws. If they want to participate in a rock, paper, scissors duel, they will be added to the back of the lineup. Okay? So players here are going to compete based on the order that they're added to the vector. Okay? So let's go back to the requirements and just talk over a couple more things before we give a demonstration of a working version of this program. So part 3 says create your player. We've given you a few requirements here to kind of guide you. You can certainly use the class that we provided in Lab 8 to guide your construction of your own class. So here are a few requirements. You need to have private data members to store the name, the number of wins, the number of losses, the number of draws. You probably want to have a constructor. That'll make it easy to initialize and create new player objects. And then you also want to have at least these member functions. The toString will be really useful for printing out all of the players. Remember, when you do option 1 in the menu, you need to show all players as well as each player's win, losses, draws, and winning percentage. Okay, and maybe you'll use the getWinRecord function in that toString, and then a getRPS throw to essentially give you a rock, paper, or a scissors. Okay, so there, we just have a few more requirements. Feel free to read through those, and let's get to the working implementation. Okay, so if I show all contestants right off the bat, there are no players. We haven't added any. If I show the current lineup, there are definitely none, because if there are no contestants, we can't have anyone lined up to play. Let's go ahead and add a player. His name is Brian. He's been added. Okay, so let's show the contestants. We see that he's initialized right here. Okay, let's add another player. Let's call him John. You see John is also added. And let's add Paul. Okay, so we have 3 contestants. Your program needs to handle as many as possible, but let's just go with 3 now because that's a manageable number. Let's add Brian to the lineup twice just to make sure that our automatic draw mechanism works. So option 2, show current lineup. You see that Brian is in both slots. Okay, so let's try and fight. Okay, so fight initiated between Brian and Brian, that's a draw. And then we go here, we see that Brian was given 1 draw, and his winning percentage is 0 because a tie doesn't count. Okay, so just a couple other things we can check. Let's say I want to add Brian again. Player's already in the tournament, cannot be added. Okay, so it looks like there's not too much to check. Let's try fighting when no one's in the lineup. Lineup does not contain enough players. That's great. So let's just add a few more players to the lineup and get a feel for how this works. So Paul, let's add John, let's add Brian, let's add Paul. So let's see how that looks. So it's like it's Paul versus John and then Brian versus Paul. Okay? Let's go ahead and fight. See, fight initiated between Paul and John. Paul throws rock, John throws paper, John wins. Okay? So it looks like John is going to get a win, and his winning percentage will be 100. Okay? Let's do another fight. Fight initiated between Brian and Paul. Brian throws paper, Paul throws rock, Brian wins. Okay? So then Brian should now have a win and a draw. Winning percentage 50. John is going to have a winning percentage of 100, and poor Paul is going to have 0. Okay? So this is about it for Lab 9. Conceptually, there are a lot of moving parts, and it can seem daunting, but really, once you get your player class implemented, you just have to make sure that players are being added into the player's vector when they're created, and then they're added into the matchup vector when they want to get in line to fight. After that, the fight function should be pretty simple, and it shouldn't give you too much grief. Just make sure that your class is implemented correctly. Okay, good luck with this lab, guys, and hope you have fun with it.